Namaskar. Welcome to Divine Chemistry. I am Divyashri. So in the previous video we have learned about the VSEPR theory, and in this video we will be learning about the shapes or geometry of the molecules containing bone pairs or bone pairs and lone pairs. So I have given this table in the previous video also, but in this video we will be going through it in a quite detailed manner. So let's get started. So if the total number of electron pairs is 2, then the geometry will be linear, and if both of them are bone pairs, then the shape will also be linear, and there might be various examples like carbon dioxide, BeF2, BeCl2, AgCl2, etc. If the total number of electron pairs is 3, then the geometry of the electron pairs will be triangular planar, and if the 3 of them are bone pairs and there are no lone pairs, then the shape will also be triangular planar, and there might be various examples like BF3, etc. Again, there might be another case with 3 electron pairs, that if the number of bone pairs is 2 and number of lone pairs is 1, then obviously the geometry will be triangular planar, but the shape will be bent or V-shaped as shown in the table, and there might be various examples like NO2, SO2, ozone, SnCl2, etc. Now, if the number of electron pairs is 4, then the geometry will be tetrahedral, and if 4 of them are bone pairs and there are no lone pairs, then the shape will be tetrahedral again, and there might be various examples like methane. But if in the case of 4 electron pairs, if 3 of them are bone pairs and 1 lone pair is present, then the shape will be trigonal pyramidal. And example is ammonia. It's a very popular example. Its shape is trigonal pyramidal, and there might be other examples like PCl3 and Cl3, etc. Again, if in case of 4 electron pairs there are 2 bone pairs and 2 lone pairs, then the shape will be bent shape, alright, because 2 lone pairs will be present and 2 bone pairs will be present in the tetrahedral geometry, and thus the shape will result in bent shape, and the example is water, H2S, etc. Now, if the total electron pairs is 5, then the geometry of the molecule will be trigonal bipyramidal, alright, and the shape of the molecule, if means if all the 5 electron pairs are bone pairs and there are no lone pairs, then the shape of the molecule will again be trigonal bipyramidal, and the popular example is PCl5. Now, if 4 of them are bone pairs and 1 lone pair is present, then the shape will be seesaw, because there is one more point to note here, is that the lone pairs always tend to occupy, means mostly they tend to occupy the equatorial position. So in the case of trigonal bipyramidal geometry, if one lone pair is present, then it will occupy the equatorial position and the shape will be seesaw, and the example is SF4. So the shape of SF4 is seesaw as shown in the given table. Again, there might be 3 bone pairs and 2 lone pairs. In that case, the shape will be T-shaped, as I have already mentioned that the lone pairs tend to occupy the equatorial position. So if 2 lone pairs are present, then 2 of them will occupy the equatorial position and the resulting shape will be the T-shape. An example is ClF3, etc. Again, if there will be 2 bone pairs present and 3 lone pairs present, then the shape will be linear, because all the 3 lone pairs will occupy the equatorial position and 2 bone pairs will occupy the axial position, and thus this shape will be linear. Example, xenon fluoride, etc. Many more examples are also there. Now, if the total number of electron pairs is 6, then the geometry will be octahedral, and if all the 6 of the total electron pairs are bone pairs and no lone pairs are present, then again the shape will be octahedral. Example, SF6. Now, if among the 6 electron pairs, 5 are bone pairs and 1 lone pair is present, then the shape will be square pyramidal. In this case, you see, the lone pairs are occupying the axial position, not the equatorial ones. So here this shape is resulting into square pyramidal, and the example is ClF5. Again, if 4 bone pairs are present and 2 lone pairs are present, then the shape will be square pyramidal. Here again the lone pairs are occupying the axial position, and the bone pairs are present in the planar position, in the planar one, the planar position. So the geometry is octahedral, but the shape is square planar. Example XCF4. So this is the table which gives us some idea about the various geometry and shape of the molecules, which we can find out from the VSEPR theory. And the geometry or shapes are forming like this type, or the geometry or shapes are resulting like this. This is because these are the shapes which have the minimum repulsions among them. Because suppose we have 6 lone pairs. In the case of or suppose we have 6 electron pairs, then when we have 6 electron pairs, then octahedral is the particular geometry which have minimum repulsion and maximum stability. Similarly, suppose we have 4 electron pairs, then tetrahedral is the geometry which have minimum repulsion and maximum stability. So this is the reason why we are getting this geometry, or why we are getting these shapes. So this table I am taking from Pradeep's. Please go through the table. It gives us a basic idea about the various shapes and geometry of the molecules, which we can find out from the VSEPR theory. So this is all for today's video. Thank you so much for watching, and thank you so much for listening to me. Please share the video with your younger brothers and sisters, and with your friends, and anyone who is interested in learning the basics of chemistry. And yeah, if you like the video, then please give it a big thumbs up, and if you want to say something, then do write it in the comment section below. And yes, stay at home, stay safe, take care, and thank you.